Okay, so we'll get started. Welcome everyone to the July Power Systems Virtual User Group webinar. This is Joe Armstrong, your usual host. Just to kick this off a little bit today, I want to wish everybody that you're safe and healthy. This pandemic thing I think is dragging on longer than people originally thought, and we're certainly settling into what everybody calls a new normal, but it's settling into some new way of doing things. And I have to tell you, I'm getting a little webinared out. I hope I think this will be an excellent webinar and really hold your attention. But with everything virtual these days, besides just the regular webinars that we have, and we do quite a few at IBM, seems like it's just webinar after webinar. But I think this one will be really interesting. So today, well, actually, before I get to that, I do have one kind of announcement. The October TechU, my favorite conference, is going to be virtual. If you probably haven't guessed, we're not going to be out of the weeds by October. And so, you know, we did the May TechU as virtual, and it's been announced that the October one will be virtual as well. It's nice. I guess more people can join. It's kind of nice to see it. It's a real bummer not to be able to actually meet people face-to-face and get to talk to the speakers face-to-face, and I think it's all much more interesting that way. But it does allow more people to see it. So just to let everybody know that when it gets closer, I'll put some links on the wiki about what the sessions are and how to see what they are and where they are and when they are and that kind of stuff. So I'll talk more about that in the upcoming sessions. Okay, so getting on to today, we're going to talk today about announcements that were held in July. So earlier this month, we had some announcements on scale-out servers. We have some new models. We have some new features, something special for the IBM I crowd. So some exciting stuff in all Power 9. So none of this is Power 10. So there's all some new Power 9 stuff that should give you a little hint that Power 10 isn't imminently happening later this year, which I heard somebody ask me about. So it's not that close, but we have some cool new Power 9 models to talk about. So looking forward to hearing about those. The presentation for today is out on the wiki, so you can download that. And I'll ask you that if you've got questions, certainly type them in. Please type them in the Q&A panel, not the chat panel. That way we can not have to look at two different panels. And so we'll have somebody looking at those. And I do think also that we're going to have Nigel Griffith on, and I do see him, so Nigel, make you a panelist. And Nigel can help answer some of the questions as well while our speakers are presenting stuff. So if you have questions, feel free to type them in. Actually, today we've got two speakers. They are the offering managers for the announcement. So we're excited to have two speakers. You might have heard us chatting a little bit before the webinar, before I started it, kicked it off here. So let me tell you a little bit about them. First, Daniel Goldner is with us. He is the offering manager for the scale-out servers, the new models. Daniel's got 16 years in the IT industry, experience in IT infrastructure, applications, services, consulting, cloud and analytic solutions. Daniel started his career in some startups, moved up his professional growth into large companies like IBM, worked for Lenovo, and he's always seeking to articulate and navigate business and technology practices. So Daniel is responsible for the IBM scale-out systems, enterprise scale-out systems offerings worldwide, and he's a big enthusiast of the hybrid multi-cloud solution. So you'll hear Daniel talk a little bit about how these really fit into hybrid clouds with this new stuff that we've got going here. So our other speaker is Douglas Gibbs. So Daniel, first of all, I'll tell you, Daniel's in Brazil. Douglas is in Canada. Douglas is the offering manager for the Power Systems I/O. So he covers the whole I/O brand for I/O part of the all the Power Systems. Douglas has been with IBM since 2005, extensive experience working with a variety of IBM and third-party software and hardware systems, and been a member of the Power team since 2012. He started with performance, always the performance team, always a great place to be, and then took on this role of the offering manager for the IO in 2018. So we're happy to have Douglas here as well. We're going to kick off with Daniel is going to start us off here. So he's got his slide deck up. And with that, Daniel, take it away.
Okay, thank you. Thanks for the introduction, Joe, and thanks for the invitation to get the stage here on this call for this such special audience we have today. It's really an honor to be here in my first product announcement, right, in my role. Maybe some of you that were already there in the webinar heard it. I started the offering manager role since January this year. So it's been quite a challenge, right, to take a worldwide offering role. And 2 months later, we got hit by a pandemic. We got hit by global economic recession. We can't barely leave our houses, but this is the way it is, right? That's unfortunately the reality we have today. And all we can do is to make our best out of it and get it passed over and move on, right? So I hope, I really hope and I wish you guys are safe there in your families or your loved ones, and then we can. I hope. I really want to meet you guys face to face as soon as possible. I really like to have this face to face conversations. Can be a meeting, can be a beer after a meeting, can be whatever. So I really enjoy being there, sitting with customers, IBM business partners, IBMers all over the world. It's really important. It changes the dynamics, right? So when we are face to face and can discuss about things in more depth. But while we are not there yet, let's make the best out of a webinar. So thanks again for your attention and for your time today. The objective here actually is to go through the announcement we did on July 14 related to scale-out systems. You might have seen a bigger announcement from IBM Power Systems on July 21st, kind of 1 week after. That bigger one, it's basically a broader announcement that includes the scale-out announcements, plus some other announcements and new features we have in the portfolio. So, but basically everything goes towards the same subject, the same area, and the same approach, which is hybrid multi-cloud. So IBM Power Systems is really moving fast and very strong towards this kind of environment, right? This kind of deployments, because we have the best systems for that, right? And we have not the best systems, but also the best software. So July 21st announcement, we announced SAP HANA support on the IBM Cloud on Power. So we can have Power Virtual Servers, Power VS we call, Power Virtual Servers to run SAP HANA, certified by SAP. And you can start thinking more in a more robust way, in a more enterprise way, on making kind of a hybrid cloud or hybrid multi-cloud for SAP HANA. We announced support of 3 new cloud packs on Power Systems. So now we have Cloud Pack Multi-Cloud Manager, Cloud Pack for Apps, Cloud Pack for Data, and I'm sorry I forgot one of them. There's another one I don't forget. I just forgot, but I think I have here later in the presentation. So and we also announced, not that actually we announced, but we kind of refreshed and boosted also and made it very, we gave this another topic the importance it has, that is the Ansible, Red Hat Ansible support on Power. And Red Hat Ansible is such an amazing tool we have. Came from Red Hat. It's an automation tool. I'll talk a little bit about it later in the presentation, but this is an awesome tool for us, for a power brand, and also for a hybrid multi-cloud environment, right? So, okay, let's move on here. No, I just opened LinkedIn. So here you have, by the way, you have our emails here, my email with Doug, and also you have the LinkedIn to our the link to our LinkedIn profiles in case you want to connect there and make your questions there, or just stay tuned for the announcements. I'm really making an effort to share very often some news and thoughts around hybrid multi-cloud. I really like this stuff, like discuss it, to hear ideas. So if you want to just go there and stay connected, that would be a pleasure. Okay, so hybrid cloud. So first thing in the presentation, I will kind of set the context of the announcement. So why are we announcing new refresh systems, right, for the scaleout systems? Let me set the context, right? Why we are doing that. I try not to try, but I will connect that to the hybrid multi-cloud story, because this is if I would just make it in a few words, that's why we really want to make these systems the best for hybrid multi-cloud, and that's what we work towards. And after that, I'll cover what are the main features, main topics of the announcement, the main enhancements, the main news. Then Doug will cover what's new around the I/O, right? You will see that one of the biggest things about this announcement is I/O, is throughput. So it's good to have Doug here to give us more detail around it. And then I'll just show you some more details about the systems. I don't plan to spend much time about it, but at least it's going to be there for your reference, and you can check it later. And then we close for Q&A, right? And just make your questions out there in the Q&A session here in the WebEx. Anytime, place your question. Don't leave your question behind. Just make it there, because it might be the question for someone else. And as we were used to hear in the school, there's no bad question, right? All the questions are good, and this is the time for us to have them clarified. So let me start with the context, right? So again, it's all about hybrid multi-cloud, right? And we hear a lot about it from IBM, not only IBM Power Systems, but IBM, and now, and very recent, right? We bought Red Hat. So 1 year ago, IBM acquired Red Hat, and the reason to do this acquisition was hybrid cloud. So IBM is really the key player and the main player on this cloud discussions in the market. IBM has strong and solid public cloud. IBM have now more than ever, we have the best tools for a hybrid multi-cloud, and we also have the best systems for that. We have IBM Z, we have Power Systems, we have IBM Storage, right? Of course, we don't have the ingenuity of thinking that everybody will run only on Power Systems and Z and store. And we can run everything on our storage, but we can have also x86 systems. Some workloads would run better there, but we have the best systems for the mission critical part of it, right? So I'll discuss that with you here, and I really expect that you guys see that what is the real and key benefit that makes us far away from competition when you talk about hybrid multi-cloud. So according to IDC, here I have some numbers. IDC and IBM Institute of Business Value. This IBM has a kind of an organization inside IBM to make this researches, to make this reports to the market. So 98% of the organizations will use hybrid multi-cloud by 2021, which is next year, right? So if 90% of the organization will be there, imagine how many today are there, right? So most of the organizations are there. It's not that will come from 0 to 98% in 1 year. So most of them are already there, already operate in a hybrid multi-cloud world or environment, right? Or architecture, right? And also another important number here, 31% of this compute capacity will be on private on-premise cloud. But what I wanted to make to highlight here with this chart. Even though most of the organizations by next year will be running on a hybrid multi-cloud or having multiple cloud deployments, we should think about and ask, did these customers or these companies get there in a structured way? Was it planned? Was it part of a journey or a roadmap to start with one cloud, then another cloud, then other cloud, then some other on-prem deployments that put everything together? Was it a planned journey? Or was just like there's the one department just started using the Azure cloud, the other departments by themselves started to use IBM cloud, the other department by themselves bought a small server, put under the desk, and then several business units just requested to IT to have their specific servers. I mean, it can be very messy, right? And I wish we could be just in a room here. I could ask you to raise your hands, right? And ask, was or did your company, your organization, and I even ask that to the business parts that we have here, because we're all working to companies, right? Did your hybrid multi-cloud journey was a planned journey, right? So it might have been, right? But most of the deployments we have today, they were just not thought about it, right? We just got there. So, and that's pretty much what the approach that IBM has. I mean, we can even help you start your journey if you haven't, or we can help you have a better hybrid cloud environment and architecture. Because if you didn't do that before, there's always time and the need to do that, right? To have a proper, organized hybrid multi-cloud environment, so we can actually maximize the potential of what you invest, right? You can invest a lot of money, a big amount of money, but not just be able to maximize what you spend, because I mean, things were not just thought about in a synergy that is needed for this kind of environment. It can get very messy. I'll show that to you. So the main use cases for hybrid multi-clouds and specifically related to Power Systems. Maybe this is not new for you guys that are working in this kind of deployments already, but cloud scaling is one of the big ones, right? So when you talk about cloud scaling here, it's scaling up and scaling down, right? Which scaling down is something that we are not usually think about. So it's always about growing the capacity, the processing capacity, but sometimes it's just not about it, right? We just don't have all the demand, and just need to scale down. This is something around flexibility, and you can just do the scaling on-prem or on the public cloud, and you gotta have the same experience on doing this kind of compute adjusting or compute capacity adjusting the same way. It has to be seamless, right? Another very traditional use case for hybrid multi-cloud is HADR, right? You can even have one on-prem, the other one in the public cloud, or vice versa. Pre-production, so have your dev, QA environment in one place, and production other place. So, I mean, consistent experience I just mentioned to you, unified cross management across all clouds. So management is the use case for hybrid multi-cloud. Because I mean, you can just have only on-prem systems, and you can even struggle with management of all these environments. Or you can just have multiple. You can be 100% public cloud, but you can still struggle with the management. So managing these environments and not having to give up on one deployment, right, because of management is a big thing. And I wanted to make a comment here because from my experience with a lot of conversations with IBM clients, and mostly in Latin America, but that's most of my experience so far. But I heard a lot of customers saying, look, we are simplifying the standards of our infrastructure. So I would just have VMware, I would just have, I don't know, x86, and that's it, right? I want to simplify it, makes the management much easier. So I heard it a lot. And I really struggle with this kind of argument or decision, because when you do that, you're just shutting your eyes to other great products in the market or better products in the market, considering workloads, considering other variables, right? That is not just the management of the infrastructure. Management of the infrastructure is just one thing. I'm not saying it's not important. Of course, it is important. But why prevent yourself to maximize what you can get out of your money or your IT budget by having different players in your data center, because you just can't be effective enough in your management, right? That's something that I don't get it. So, and especially now that we have tools, and related to my first comment as Ansible can just work across any platform. Can be Windows, can be Linux, can be AIX, IBM I, can be on x86, on Power. If I'm not wrong, it can be on Z. So you can just automate anything. You just automate to create playbooks, and you automate, templates, how the microservices will be deployed, how virtual machines will be deployed across the entire infrastructure. So, what's the struggle about it? You better have a heterogeneous infrastructure on your data center, or whatever your workload is running, or your public cloud, and you can just optimize your management, right? Make your management very lean, optimized. You don't have to mind about not making the best out of your investments because you just don't want to afford, or you just can't have a better management of all of it. So management here, it's a key use case for hybrid multi-cloud. And obviously, the more we scatter, the more instance we have to compute, the worse the management can get if you are not ready for it. If you just don't sit and plan and do something about it, right? So based on some IDC, also IDC studies here, you can see in the bottom of the chart, the reference, what clients are asking for in a private cloud. So I want to highlight this, infrastructure scalability and agility. So that's pretty much the same use case I mentioned before, right? To be able to scale up or down the capacity as needed, right? So you avoid having the cost of idle capacity all over the infrastructure, or even worse, just lacking capacity and just slow down all the workloads because you just can't just scale and upgrade anymore. Total cost savings. So TCO, right? Total cost of ownership of all of your architecture has to be optimized because our IT budgets are very limited. It kind of relates to the idle capacity. Cloud experience in a central IT control. So you see that the use case I just mentioned to you, they all relates to what IDC is pulling all over the world with IDC's contacts or IDC kind of customers. So having this a seamless experience to manage your workloads on multiple public clouds and multiple on-premise clouds, but has to be a single pane of glass, right? It has to be the seamless management as possible. So don't avoid having multiple passwords, multiple systems, to multiple everything, right? The more we can simplify, the better. And I think that all of these three will just make it a better and improve time to market. So if you can have a seamless management of the environment, and your infrastructure have flexibility enough to scale up or down, you can just make it a much faster time to market once you get a request, right? Just go there to this kind of single pane of glass. You can go to the Ansible playbook, just deploy a template you have there, and the capacity will always be there to respond to it, and that's it. So this is what customers are requiring for private cloud. Let me just now talk about the infrastructure side of it. And let's make a parenthesis here. So, as Joe said, I'm from Brazil, so you probably noticed the accent. So if I say something you just don't understand, I'm sorry, but I'm doing my best. But just put in the chat here. We can just repeat anything. So going back to the infrastructure discussion here. In the past, most of you will relate to that. We had only the on-prem systems. Then we started to have public cloud offerings, and we start to split the processing, right? Data storage and processing. So it's just make one part of the processing happening in one place, the other part of the data processing happening in another place. And then we started to use more public clouds and more on-prem systems, right? To the point that we start to talk more recently about edge computing. And edge computing is nothing else but a distributed computing in multiple systems in different places, right? And multiple systems can even be mobile devices, right? Just run an AI inferencing model in a mobile device in a certain place. This is a processing happening, right? And it's an enterprise processing happening. So, I mean, having systems in remote locations to closer to the business, where the business is happening, it can also be called edge computing, or in more technical and more established terms, distributed computing, right? So it can get as bad as this picture I have here, right? So maybe some of your companies, the companies you work for, have this kind of situation I've just laid out in the chart in the gray area. A lot of multiple clouds, which are these blue clouds here, and multiple compute instance, right? So when we talk about hybrid multi-cloud, we talk about compute instances, or instances, places, or however it best suits the language here. But basically, I like the instance word. So basically, where the processing is happening. And you have a lot of places that is happening right now. It's not that much consolidated in one place. If you're talking about a big environment that has a high-end system that consolidates the OLTP server, the OLTP system, a legacy system, that will kind of consolidate, right, centralize some key critical processing. But today, with digital transformation, with a lot of things going digital and being transformed, a lot of processes being digitalized, it's crazy how much more workloads we have today to process and to manage, and how different they are from the legacy system, right? So it starts to get very crazy, because you can have an application running on a public cloud, and accessing a database running on-prem, and you can have vice versa, or you can have microservices running in a specific on-prem deployment, and these microservices will have to migrate somehow, and for any reason, to a public cloud. So when I put here the arrows, is because all the devices, all the compute instances, they have to communicate to each other. And I could just put some storage boxes here close to all the systems, and basically this is it. The server and the storage having a lot of requests from multiple places, right? So there is a network challenge here, but there's also a data transfer rate challenge here. So the systems, or the compute instances you have, they got to be able to deal with more and more data volumes moving in and out of the systems, because the processing is not that much centralized on them as it used to be. So in the past, we were more concerned about the performance of the cores, of the motherboard, I mean, everything inside the system, because pretty much everything was happening inside the system. Now, in a hybrid multi-cloud world, one system doesn't work alone, right? If I may say, this is a teamwork. So a lot of data have to be coming in and out of the system, because one system, one compute instance here might just receive a request in 1 second, multiple requests for a big chunk of data for multiple different microservices running in different places. It can be very crazy. And the system that is being requested has to be able to respond to it. Otherwise, you just get a hop, right? You just have a downtime in your hybrid multi-cloud. So to make sure you have the right SLAs to the business areas in a hybrid multi-cloud world, it's about serviceability, right? But it's also about how the system can respond to the demand, right? It's about the reliability of the system. It's about security of the systems. It's about serviceability. It's RAS, but it's also how much the system can handle. So we figured out, I mean, we heard feedbacks as this whole hybrid multi-cloud story matured, that data transfer rates become a struggle, right? So I can have multiple systems, but if these systems just don't have the doors, right, the bandwidth inside the system wide enough, I just can't work. I mean, I have to create lines, backlogs in the system. It's crazy. So this is one thing. So multiple compute instance, I'm kind of walking through the bullets here in the top. Multiple compute instance, I just mentioned that. And compute cloud performance is also, every time it's also about performance, right? So what's the point of having the data being transferred all over the places, but when you get to the server or to the virtual server, it doesn't have the performance you need, right? So what's the point of getting all the data there if you just can't respond in time? So these three things here became the struggle regarding to infrastructure itself, right? And that's where these are the three areas we worked on. These are the three areas that once we listen and understand the need, that moving forward, as the hybrid multi-cloud environments, they get mature, they get more complex. In terms of infrastructure, these are the bottlenecks. These are the most need right now. So that's what we work on. This is what we work. These are the three areas we sit down and say, look, we have to make better systems to accommodate this kind of demand, right? I think I heard someone unmuted. Is that a question or?
No, no questions that,
okay.
that you need to go to yet. Daniel.
Oh, okay. I use the pause here for a drink of water. So, so here, if we will talk about managing here, the management of all of it, I just put some Ansible icons here to see. But there's another story about hybrid multi-cloud infrastructure. If this discussion was about hybrid multi-cloud as a whole, not just the infrastructure, we'll certainly be talking about management here, right? About OpenShift, about Ansible, about other tools. And because that will be kind of the fourth bullet here in this chart, right? Management. So bringing it all together. So understanding that almost all the companies around the world have a hybrid multi-cloud environment somehow, right? Even planned it or not planned, but they have. Understanding what are the requirements for a private cloud, which are flexibility, a central IT management, a kind of a seamless experience to manage all the environments, improving the TCO story around it, right? Making it more affordable. And about the infrastructure, specifically about the infrastructure, I mean, data transfer rates, the multiple compute instances we have today, and the performance we need in each of these instances. So bringing it all together, that's the context, right? That's the stage where we just stepped up and said, look, we need better systems, right? Even better systems to accommodate this kind of demand. So now we have, and we can say we have the best systems for hybrid multi-cloud. So here I highlight the three main changes on this system. One, I'll walk through from the left to the right. 2 times more throughput here in this system. So we improved dramatically the throughput on these systems. And I'll let Doug talk more about it. But on the S914, S922, and the S924 systems, if you are, familiarized with the scale-out systems at IBM, these three systems are being upgraded and enhanced, right? These three systems now have 2 times more bandwidth than the systems we had so far, so until now. So the thing is, when we announced it Power 9 back in 2018, the scale-out systems, they were a mix of PCIe Gen 3 components and PCIe Gen 4 components. But while you have PCIe Gen 3, the speed is PCIe Gen 3, right? So now we have a full redesigned system. It's a new motherboard. So for you to see how deep the change is, it's a new motherboard that is full Gen 4. So all these slots, PCIe slots are Gen 4. The ones in the back and the ones in the front, they're all PCIe Gen 4. The backend switches on the PCIe adapters, they are now Gen 4. They were not before. And all the lanes in the system, they're also Gen 4. So basically, this is 2 times faster now. This is a true PCIe Gen 4 system. So I challenge you guys to check on the competition to see who else has such a system, like full PCIe Gen 4. This is not an easy information to find in the web, so I just can't go there and Google and make sure we are the only ones. But I will guess if we're not the only ones, we are around the very few ones that have such a system, right? I'm not talking about the PCIe slots, because having PCIe Gen 4 slots today, it's easier because you just put the slot there. But if inside the system, the communication goes on PCIe Gen 3, then what's the point, right? So these systems now are full PCIe Gen 4 systems. Other than that, we also increased the NVMe support, capacity support for this system. So we doubled or tripled, if I may say, the capacity and the amount of NVMe devices we can have in each system. So for example, the S914, until now the maximum NVMe support there was 3 devices. Now we can have up to 11, from 3 to 11 devices in a tower server, NVMe devices, right? This is really bold. It's really enterprise-wide. We talk about the rack systems, S922, S924. We're moving from a maximum of 5 NVMe devices up to 14, 3 times more. So when we talk about NVMe, this is the fastest way to rest the data today. So imagine the amount of IOPS and the speed you can have in a system that needs to be now more accessible and more available to get data in and send data out, right? And the data that is sitting on the NVMe's. So what we did basically is we increased the doors, right? So the doors to go out and in. And also we increased the speed of where the data is sitting inside the system, right? So data is sitting there, but it's not like rested, right? It's really active and very fast to have this data accessible. This is one thing. The other thing here is the column in the middle. As I mentioned to you, flexibility is a key thing for hybrid multi-cloud environments. So we decided and we finally introduced IBM shared utility capacity to the scale-out systems. This is a feature best known out there as Power Enterprise Pools. Those that are familiarized with the high-end systems, E980s, E950s, or the older generations, this is it. These systems work in pools since Power 6, I guess. And this is a long run that IBM has pay-as-you-grow experience in infrastructure. And now we have it available on scale-out systems, right? So you can have the flexibility you need on-prem as you have in a virtual server. So if you go to IBM Cloud, you can just buy a specific virtual server with the amount of cores, memory, etc. But still you have some standards, right? You have a minimum. And here's the same thing. You buy the system by the minimum. You can have a S922 or S924 system in your data center, paying as minimum as 1 core and 256 gig of memory. And but all the capacity is going to be there. I mean, you can have a 20 physical core system, but only one core active there. And if you need more capacity than what you have in your base, in the minimum you bought, you will pay by the minute of the capacity you will use. So this is really great news. I'll share more details on that. And the third column here is the performance. We added 2 new processor options, and that is specific about the 2U server, the S922. This server now has a 1-core processor option and an 11 cores processor option. So the maximum before was 10 cores or 20 cores in the system. Now this system can go up to 22 big cores, right? That's how we call the power cores. It's a big core. So we increased the system performance by 10%, right? So these are the main news around these systems, right? And these, gentlemen, these are the new scale-out systems for IBM, right? These are systems with a much faster I/O capacity and performance, more performance in terms of processing, if you talk about the 2U system. And all of this get you to more savings, right? If you have better cores, if you have better systems, you can consolidate more. And when you talk about hybrid multi-cloud, most of it is licensed by core. So we have an example here, talk about saving. if you want to license a cloud IBM Cloud Pack in an IBM system, it can be 3 times it can have 3 times better TCO than just running that anywhere else, because the license by core, and we can have a container density as much as 3 times more containers per core than x86. IBM Power Systems have big cores, right? So our big cores get us to this kind of story. So one curiosity is that IBM Power Systems is being developed for so many long years. I mean, so many times, right? Always on the architecture, sticking to the core of the platform of having big, powerful cores. So you see, technology just evolved. Now we talk about containers. And when we started developing power systems a long time ago, obviously nobody was thinking about containers, but still, when you put up a new technology that is new virtualization technology that is containers, power system is already the best one for that, right? We didn't have to redesign anything. The system is there, the platform is there, because the platform is a differentiated platform. So bring in the workload, and we show that we are better. So look at containers. One core in power system can get 3 times more containers than x86 system, or x86 core. So about the private cloud solution we have on the power system. So and about IO, Doug will go through that in a minute. So let me focus here on the flexibility on the payment of this. So now you can get the system as low as minimum as 1 core and 256 gig. You pay a minimum here. And this is not new for Power brand. This is the Power private cloud with shared utility capacity. That's the new name for Power Enterprise Pools. And it exists already on the 980s, 950s, you see here in the chart. And now you can have it in the S922 and the S924. The S914 is not yet on this kind of approach or offering, but depending on feedbacks and how the offering evolves on the scale systems, we can add the S914 to this offering as well. It's basically what we're doing now is rolling that out in the scale out portfolio. So we are kind of phasing it. And now that we announced, we have the prices out there, everything is out there. Let's see how it will work, and we will start adjusting the offering accordingly, and mostly based on feedbacks from you guys. So what we do here is enable you to have a flexible capacity on-prem, right? It's having a system on-prem, whatever you want to have it, can be your data center or a third-party data center, but this is a flexible system, flexible capacity. You pay for what you use, right? So some of you might be thinking already about our competition. So HP GreenLake has it, Lenovo has it, Dell has it, Oracle has it, but they're not the first, because we had it for a long time in the high-end systems. Now what we're doing is just making it down to the 2-socket systems. So you can buy the system as minimum and pay by the minute. So one thing I want to highlight to you, once you have this system, you just purchase servers with the base capacity. The base is the minimum you need to start, right? That's you will pay upfront, kind of as a regular server. So to start off your project or implementation of the workload you have, you need 2 cores, 3 cores. Okay, that's what you're paying, right? You can ask for the install capacity to be 16 cores, 20 cores, up to 24 cores in the S924, but you'll pay for what you need in the beginning, right? The only minimum requirement here is 256 gig of memory, right? That's the minimum of the offering across all platforms. Once you start with the 256 gig of memory, you can increase that any way you want. You can add just two more DIMMs, 4 DIMMs, whatever you want. There's no block here, right? Just as granular as the DIMMs are. And when you start on that, right? So you get the system in a base capacity. So you get capacity credits, which are basically some prepaid credits, or you can even do this postpaid, but there is a kind of a restriction on the operation. If there's more time, I can explore it more with you. So basically, have their minutes pre-planned for the extra capacity, right? So that will be metered by the minute once you need it. When you don't need it, this is it. Also, if you have more than one system, in this kind of shared utility capacity way. These systems can be part of the same pool. And when you talk about pool, is that these systems will work as they were one system. So they will share core activations and they will share OS entitlements. So you see here in the pink, in the bottom part here, you have a base and a meter capacity. The meter capacity is around processor activations, AIX and IBM license, and memory activations, but memory activations is only on the high ends, on the scale. So high-end systems can get to up to 64 terabytes of memory. So it makes more sense to scale that, right? To make it an activations, to make it as you go. But on the scale systems, we get up to 4 terabytes. So we would rather just make it static. You buy the memory is yours. Memory is not a resource to spare mostly, right? So we will not have memory activations in the scale-out systems as we have in the high ends. It kind of simplifies the offering from a scale-out perspective. Once you have your systems deployed, you'll have IBM Cloud Management Console connected to your HMC or virtual HMC to manage your pools. So this screen here is seen at the top, right? This black screen here looks much blacker than it is, but this is the CMC screen. And from there, you'll manage your pools. You can have a pool of high ends, a pool of mid-range, a pool of scale-out systems, and you manage everything in a single pane of glass, right? Talking about simplification on the management, this is it, right? So for companies that already have the high-end systems, IBM high-end systems, here, if you just want to have the same experience you have in the high ends, but in the scale-out systems, now you can have it. You already have your CMC console, your CMC, and you can just add a new pool there and make the scale-out systems work the same way. You can manage your IT budget for the high ends. You can manage the IT budget the same way for the scale-out systems, right? This is what we call a seamless experience. One of the examples, of course. We're talking about IBM infrastructure here, but makes it very simple. So what are the capacities here? So I laid out here in S922. So bear with me here from the bottom to the top. So the gray area here is what we call permanent capacity or static or base capacity. That's a CapEx investment. Right, so you can get a box and buy the permanent capacity as minimum as it is allowed, which is 1 core and 256 gig of memory. That's what you get, right? So you can start. Let me see if I can draw here something. Okay. So you get the full system like this, but you're paying only for what is in the gray area, right? The rest of the capacity here in this blue and white is available to you. So imagine you're running a workload and you need more capacity than what you have in the gray area here, that you paid for it already. You will pay there upfront or you can lease it, but it's yours. If you need to use additional resource in the system, it's represented here by the blue area. So you see that's kind of a wave because it's dynamic, right? It flows. One day you can use more capacity, one day you can use less capacity, or you can just not use the capacity, right? So the blue area here is the pay-per-use capacity being used, right? And it can be, depending on the accounting rules on the company, can be classified or paid as an OpEx. So you just have the system there, but the resources you get, you can classify part of it as CapEx, part of it as OpEx. And basically, this is a capacity you're paying by the minute here because the capacity credits are by the minute. So let me just jump to another chart and I'll make an example out of it. And the white space here is just the capacity not being used yet. So if you have your base, you're using also the blue area here. In this case, you still have this white area, which is the additional cores and software entitlements you can get if you need to scale even more. And the white space here, it'll be also meter. It'll become blue, right? If you need to use that. Or if you're using a lot of the blue area here, you can just buy more capacity, more base, and increase your gray area here as you go in the time. And you don't have to pay metering for everything. right? So it's really dynamic in this way. Now, so what's the value proposition here on the Power Private Cloud? I already mentioned that. You can share resources across systems. If you have a multiple scale-out system out there, multiple scale-out architecture. So let me recall the hybrid multi-cloud architecture design we just saw, right? Multiple systems scattered in different places. As long as they are in the same country, these systems can share resources. So when you have multiple compute instances that basically are systems on-prem, you can buy all of these systems at a minimum capacity, right? And just share the resource with them. So you have one system in one place, I don't know, 2 cores. The other system in another place, 3 cores. Another system in a third place, 2 cores. So you have 2, 3, you have 7 total activations in your environment, right? So from this 7, you have 4 that you can just shift to anyone, because the system had to have at least 1 core active to run, right? So imagine this example, you have in one specific place, you need to use more of the system, more capacity, more cores, right? And you have, for the example, you have 3 cores there, and you need to go up to 5. But the other systems are idle. You're not using all the other cores. You're maybe running only 1 core there. So you have core activations to spare in the pool. And this cores to spare can be optimized by being used in this specific system that needs more capacity than your base. So you won't be metered. You won't be charged. When the month is finished, IBM will not charge you anything. You have to pay nothing. So let me highlight here what are the differentials from our offering than what you see in the competition. First, I'm talking about the...
Can I interrupt you here for a minute, Daniel?
Yeah.
Before you get to the competition thing, let me ask a couple of questions just to clarify some stuff. Okay. First of all, so these are pools, so everybody knows. As Daniel said, there is a high end. You can have a 980 pool. Only E980s can be in it, and actually you can get 880s in it as well. There's a 950 pool that has E950s in it, and then you have a third pool that has all these scale-out servers that Daniel's talking about here. So you can't mix the pools, all right? You can't put all the systems in a single pool, but you can have 924s and 922s in the same pool. So question for you, Daniel. All the cores on the system are active. So if you had something like Oracle on there and an Oracle license, and Oracle has to be licensed for all the active cores on a system, or for all in a pool, in a shared processor pool, are all this? Do you know in an Oracle license whether all the cores would be active? So you'd have to take that into account. You'd actually have to create a pool for it again.
No, because you have to pay Oracle for the cores that are active that you have the entitlement to use, right? I mean, so one thing we'll have to manage or to figure out, I mean, to plan for is how much of the meter cores you might need to use for Oracle, right? You can just have the system and have a higher partition there and put your Oracle there, and you'll pay the license for the higher partition core. For the cores in the partition you have, but
so you'd still be doing hard partitioning of cores that way.
Yes.
For Oracle. Okay.
Yeah. So
I'm assuming
that's,
that.
Yeah. Go ahead. So one thing that's an important question. It reminds me to say something to make it more clear here. To make it clear, this pools offering it is not technical at all, right? So from the technical side, it doesn't change anything. Technically, it's the same thing, but this is basically a financial offering, right? To give a financial flexibility on the infrastructure acquisition and utilization, right? So we minimize the TCA and how much you have to pay up front, and then from there you'll pay whatever you need and the capacity of moving on, right? So if you need to have an Oracle running 4 or 5 cores, for example. You have a higher partition, you can buy the base cores there, and for the other cores, you just use meeting, right? For the Oracle workload, for another workload.
So all that really means that if you buy the base system, the cost of the base cores is actually cheaper than metering, right? So if you
Yes.
just were always metering, you'd pay more. So you want to buy your base based on what your base usage is. And if you have, occasional spikes above that and you go into metering, that's where you save money, that you don't have to buy that pre-buy all those cores and have them sitting there doing nothing most of the time. Right?
Yes, that's it.
Okay, good. All right,
That's it.
good. Thank you.
No, thank you. And actually, one thing also important to highlight is not that the pools in scale out will not fit everybody or every case, right? That's an alternative. If you have a big base to use, you probably to buy the system full active static as we always done, right? That is available. It's gonna be probably cheaper to you just to buy the full system if your base is big. But if you have a hard or if you have a different financial planning in terms of capex and opex, and activations can be classified as opex. So depending on your financial composition in your IT budget, even though the pool system might be a bit more expensive, maybe it become more affordable because you don't have to allocate much capex on the system, but you can just plan for opex, right? So in this case, the pool system might look more interesting. And so there are specific cases, right? It's not to be fitted and suited to all the cases, but essentially this is an alternative, right? So talking about competition. So first thing I want to highlight, and I'm here talking about this part of the chart. Yeah, that's good. So one thing, we don't have any fixed monthly fees, right? So you can compare to all of the other offerings in the market, right? There's always a basic minimum fee. There's no such thing here. The only base monthly fee you can have here if you want to lease the base capacity, right? If you pay that upfront, you have nothing to pay to IBM after that, right? As a mandatory fee every month. There's nothing about it. Also, there is no limited time contracts. So you buy the system is yours, and you can run flexible as it is, as long as you want. You don't have to commit to a 3 years term, 5 years term, or when the contract is finished, you have to renegotiate and have all the struggle to renegotiate because the vendor will push you something more expensive, especially Oracle will push you a huge compliance, whatever the license on the, I mean, this is always, that's pretty much the business as usual for them. So, I mean, there's no such thing, right? Because our systems endure and usually customers stay with the systems for a long time. I mean, you stay with the system as long as you want. Right? There's no fixed contract here. You get it, you have the credits, use it. There are gonna be months you're running your base. You don't have to even call IBM, and that's it. You can stay with 10 years if you want, or more. And another thing to differentiate ourselves is the resource sharing. So you don't have to have one contract with base monthly fees with limited time for each system you have in your infrastructure, right? And if one system is idle and other system is need more capacity, you don't have to pay for the idle system and pay additional capacity for the system that's being utilized. The system that is in idle is just there. You're not paying anything. And the capacity that you paid for that, the base capacity there, can be transferred, allocated to the system you need more capacity. So this way you optimize how much you spent, right? When you bought the systems because you bought the base activations, and you're maximizing the investment on your cores by not having to meter or to pay by the minute the extra usage in specific systems that are in your pool, right? So we have one pool, one system being overutilized, other one being underutilized. They kind of offset, and the CMC, the tool, will just make the math here, the minutes you use, how much you rate to cores, etc., and you pay nothing for IBM, right? That is different from what you see in competition. And last but not least at all, IBM is the one out there with the most comprehensive approach to cloud. So we have a strong and robust public cloud offerings with Power, with x86, right, with Z. We have on-prem alternatives. We have Power, we have Z, we have storage, and we have management of it. We have Red Hat right now, which is the best one for that. Right? We have OpenShift, we have Ansible, we have other Red Hat tools, everything that can help you set up a broader, right, and most integrated and a better synergy hybrid multi-cloud architecture, right? We cannot just ignore that as you compare to other vendors. If we talk about HP, Dell, Lenovo, Cisco, these are harder vendors trying to understand the public cloud and the hybrid cloud world. And you can talk about Azure, you can talk about Microsoft, Amazon, Google. These are public clouds. Trying to understand the on-prem, right? Azure Stack, Amazon Outpost. I'm not sure if Google has an offering right now already, but you see, these guys are making their shift to the other way of the other way of hybrid multi-cloud, try to encompass everything. You can think about Oracle. Oracle has the Oracle Cloud and has the Oracle X offerings on-prem, but this is specific for their workloads, right? Try to run anything else that is not an Oracle database there or an Oracle product. You just don't have a hybrid multi-cloud architecture comprehensively, right? So thinking about that, IBM is the only one out there. The only big player out there that can actually deliver to you an enterprise grade hybrid multi-cloud environment. So we have the skills for that. And we just acquired the best company with the best expertise around hybrid multi-cloud, which is Red Hat. Okay, so let me just move to this chart before moving to Doug. Basically finish my part here. S922 entry offering for IBMI. So what Joe just mentioned about in the beginning about the exciting news for IBMI. So we have a large install base, a large amount of customers and companies running IBMI. Very satisfied with that, and this is a great tool, right? Technically speaking, this is the best OS out there, right? No question. For me, this is the best OS out there. The best solution out there for businesses is the best one. Comes with database. Stability is amazing. Well, we can discuss that and add a beer after business. But so we have a very solid market out there for IBMI. But for one specific segment on that market, on the 2U rack systems, we were missing a Power 9 server out there. We were still running on Power 8, right? That was mostly due to portfolio shifts in IBM, and we were just urging for a 2U system. Now we have one. So the S922, most renowned, most known S922 system, now has a one-core option system. So customers that have a 2U system with a one core in Power 8 can move to IBM Power 9 with one core as well. This one core in Power 9 is 2 times faster than the Power 8 in the CPW benchmark, which is really important for IBMI. The price positioning there is really competitive between S812 and S914, right? It sits kind of in the middle, but every scenario is a scenario. We need to figure out where it lands. So we're not only leveraging Power 9 technology, but we're also leveraging NVMe here. So instead of having the backplane for doing cache in local disks there, we can just use NVMe and have basically no backplane there, just use adapters. The overall system performance is going to be much faster if you do it that way. So, and you will pay, compared to a Power 8 system, S812 today, is very small amount more, right? But again, every case is the case. So effectively, this is a one-socket 2U system in Power 9, right? There's no change in the hardware design or warranty or maintenance. It's just a one-core chip, right? Actually, the chip has more cores, but it's limited at the firmware, and there's no upgrade. So it's truly one core. The same limit in the number of users as the S812, it's 25 users. And I wanted to highlight here in the bottom of the chart, 2 statements of directions we have. Statements of direction. One is the S922 only supports the 220 volts power supplies. We will now have the 110 volts power supply until the end of the year, right? Which for the US market is a big thing. And second, support IBM Solution Edition in this system. It's being planned for September, so we are almost there, and you can run IBM Solution Edition on this S922 with one core. Okay. And my pretty much last chart here is kind of summarizing everything. I wanted to mention something here in the bottom, the table. Though we are upgrading the systems, they don't change their names. So what we are known today as S914, S922, and S924, it still has the same name. Only the IBM machine type model codes here will change. Actually, one letter in the end, if you see the table. We're moving from A models, we call them, to G models, but the name of the systems are the same because these are the same systems, just enhanced, right? They're deep enhancements, but they are being enhanced. So these three systems are in the scope of the refresh, and SAP HANA optimized models are planned to be on the Gen 4 architecture later in the year. And the L922, so far, we're not planning to refresh it right now, right? Basically, we decided if we need to have systems in the portfolio to do an alignment to hybrid multi-cloud, it was not a hard decision, right? I mean, let's do with the S systems, because the S systems, they can have Linux, they can have AIX, IBM, and let's make these systems the best for hybrid multi-cloud. Let's see how it works, and we have a roadmap of investments that change everything. The portfolio is very dynamic, but this today, the scope of the announcement are the S models. And this is it. I think I took like a full hour. Let me move it to Doug. I will talk about I/O, and then I will close with one more chart, and we go through the Q&A. Doug, over to you.
Okay, thanks. So you're going to have to drive this, right?
Yes.
Alrighty. So I'll quickly go over some of the brief differences between the pre-existing A models, as we'll call them, and the new existing G models, as well as some of the new features that should be exciting for us to be able to leverage now in these G models. So let's go to the next slide. As Daniel was mentioning earlier, we do have full support for PCIe Gen 4 across all lanes. Now, what we've done is we have not changed the CPU or the PCI controller that is embedded with the CPU or the number of lanes in there. And what we've done is updated the planar and updated the switch that fans out all of those PCI lanes, such that now everything is Gen 4 enabled. Previously, you would have noticed that the items that are in darker greens were PCIe Gen 4 because they were directly connected to the chip or the socket. And everything else that was in a lighter blue here was behind a switch, and that switch was Gen 3. So what we've done is replace that switch with a Gen 4 switch to provide full bandwidth out to all those PCI slots from the switch with the same amount of bandwidth going back into the socket. As well, what we've done is change the storage configuration capabilities with a change in NVMe. So previously we had a choice between SAS and or NVMe, and we still do. On this platform though, the 22G, there's a couple of different changes in that. Notice we have new PCI slots. So we've expanded from 9 PCI slots out to 11, which is the same number of slots we have on the 4U 2-socket model. And we can combine, not combine, but we can have storage being SAS only for direct attached internal or NVMe only. And there's an update to the NVMe that I'll get into in a couple of slides. So let's go to the next slide. So this would be the 4U 2-socket server. So now it's called the 42G. You notice here that we still have all 11 PCI slots available. And what we have here that's really new is the red box in the bottom right where it says SAS only, SAS or NVMe, or NVMe only. And it says this combination of factors because we do have support for new NVMe devices. Other than that, there is no major change in the platform or in what was supported on a previous A generation server versus what's available now in a G generation server. All of the previous PCI adapters are still supported in this platform, and we do have new support for NVMe changes that I will walk you through, as I mentioned. So the next slide. And of course, we can't forget about the 41G, so this is still our 4U one socket. Exactly the same as we have on the 2 socket, of course. All the I/O that would be attached to the second socket is not available. So very, very common configuration compared to the previous generation. It's just, again, everything now is fully Gen 4 capable. We've got Gen 4 going to, obviously, from the direct attached PCI slots to the CPU, but more importantly is we've got the bandwidth going from the switch slots now to the PCI slots back into the CPU. Okay, so let's go to the next fun slide. One of the cool things that we've done here is created some new boot options. So I know that the A models, when we first released them, they had the ability to have some NVMe in a small, I like to call it a bubblegum stick M.2 model factor. We've expanded upon that. We still have now the ability to support up to 4 NVMe devices that are U.2 within the front of bay. That is something new for us. We can mix those up with SAS devices, so 6 SAS devices plus 2 NVMe devices, or we can go to an all SAS solution of 12 devices or 18 devices on the expanded functionality. That is in both the single socket and dual socket 4U models. So the 9009, what is it? 9009 41G and 42G. My apologies. And then on the S922, what we have is the ability to boot from front 8 SAS devices, which was always there, or now we can do 4 NVMe devices. And these are all front bay accessible. These are concurrently maintainable. These are not something where you have to open up the chassis and make a change to this system. As well, on all the models, we still have support to boot from any kind of PCI bootable device. So that would include the existing NVMe storage adapters that we brought out last year. That would include the existing fiber channel adapters, or if you're using network boot, we can still boot off of the network devices. So there's been no change in the support of booting from PCIe devices for your platform. Another thing that's new that's exciting for our lower PO5 tier customers is the original limitation was a boot support of only 2 1.6 terabytes. Well, if I am an existing customer and I had 3 terabytes of storage on SAS and I wanted to migrate over to NVMe solution, it wasn't so easy because I had not enough NVMe storage. So what we've done is we've increased the minimal and maximum amounts of storage, I should say, available on the PO5 tier. So I can now use 2 3.2 terabyte NVMe devices to boot from instead of only 1.6. So essentially we've doubled the amount of capacity because we've gone up a size in NVMe device, and we've now been able to match the same amount of capacity you would see in 8 SAS devices that you would traditionally see in that configuration. So it's going to make it much easier for customers who are on a configuration that is using SAS only to migrate into an NVMe and take advantage of the latest high-speed storage capabilities of NVMe devices. So let's go to the next one. Now, you've heard me talking about NVMe. NVMe is one of my favorite topics. I've talked about it a lot over the past several months, and more importantly, a lot in the past quarter, and I'll continue to. But what we have is the update on NVMe support for these G models. So the first thing that I'll mention is there is no M.2 NVMe option available. So the previous very small bubblegum stick device, that is not movable from an A model into a G model. We will not support that if you have these existing, and we did withdraw these from market early on in their inception, and people were rather frustrated with that. I understand that, and I shared that frustration. But as a result of that, what we've been able to do is bring in the entry-level point of the same NVMe device we have on the enterprise class systems. So this is a 7mm 800 gig data center class device. What we've done is put it into a 15mm carrier. So you can now use this in any one of our Power VM based platforms. It's just a different carrier on the scale-out servers versus the enterprise servers. This is a great device that's fantastic for hosting AIX, VIOS, or Linux. Note, it is not supported by IBM I. One of the key differences about this device versus all the other NVMe devices that we have is that it only supports one namespace. So that one namespace means when I look at a namespace and it's presented to the OS, it means I'll only see one H disk in AIX or VIOS. I'll only see one SD block device in Linux. And because we don't support it in AIX, you're not going to see any LUNs available. Or if we did support it in AIX, it would only be one LUN, and that would be very inefficient for us from an IBM I perspective. So those are some of the reasons why it is not supported on IBM I and why it is considered a data center device, in addition to its lower performance than the enterprise device NVMe's, and the fact that it does have a slightly lower lifespan or expected lifespan when it comes to drive write per days versus the enterprise class NVMe's. When we talk about the enterprise class NVMe's, we have introduced a new 15mm U.2 format device. This matches the same device sizes as our existing PCIe add-in cards. So it's a 1.6, a 3.2, and a 6.4 terabyte sizing. These devices are all now Gen 4. They are not Gen 3 like the existing PCIe add-in cards. So they will be able to drive more bandwidth if you are trying to maximize them out. These devices are supported by every OS on our platform. So the enterprise class devices support AIX, Linux, IBM I, and VIOS. So if you're looking for IBM I front of bay or front of server U.2 form factor, you want these 15mm enterprise class devices. Something about these devices as well is that they need to be mirrored if you want to protect your data, and you should mirror them to themselves. So you should not be looking at taking these U.2 devices and mirroring them to a PCIe add-in card. The reason being is the namespace sizes could be different because they have up to 64 namespaces versus only 32 namespaces on the PCI add-in cards. And that can result in some differences in what you would do for potential namespace sizes to maximize the capacity utilization. As well, they are PCI Gen 4 versus a PCI Gen 3. So there are some minor differences in the behavior potentially of these devices if you're going to mix a mirror between a Gen 3 device and a Gen 4 device. On the S922 servers, if you are looking to use these U.2 devices, they require a backplane. This backplane, there's two options. There is a 2-device backplane or a 4-device backplane. So that's why you see feature codes EJ1T or EJ1U here. And on the 4U servers, it doesn't matter if it's a 1-socket or 2-socket server. If you want to have 2 devices with your 6 SAS devices mixed, or if you want to go all 4 NVMe devices, you have to choose one of the 2 backplanes for the 4U model, and that would be EJ1V or EJ1W. And these are strictly just the pass-through backplanes that connect the NVMe devices to the PCI switches. And of course, as I mentioned earlier, we do have continued support for these PCI add-in cards What's really nice about the new updated switches on these new G model planers is we've expanded the max number of adapters available in these servers. So in the 2 socket models, it doesn't matter if you're on a 2U or a 4U version of them, we can now support up to 14 NVMe devices. So that would be 4 of the U.2 devices plus up to 10 PCIe add-in card devices. And the 11th slot, you would need to reserve that still for a network. Otherwise, you have no way of getting data in and out, but you would have a very secure platform, I would say that. So that is something else that's new, meaning that we now have 14 times 6.4 terabytes available as your max potential space on these servers for internal direct attached storage, which is fantastic and phenomenal when you consider the performance of these devices and the density of them compared to what we have in SAS SSDs. Okay, so let's go to the next slide. So a lot of people like to understand, what are the differences in the speeds and characteristics of all these devices. So what I have here is just the different ratings on these devices, starting at the top with that 800 gig data center or mainstream type of device that we would use as a boot-only device. You can see here that it has obviously lower bandwidth and lower IOPS. And don't forget, it also only supports 1 namespace. For all the rest of the devices, the next 3 adapters are all of our add-in cards. That's where we see the form factor is AIC. And with those cards, there's a slight difference between the 1.6 terabyte card and then the 2 larger adapters. And there's a similar difference like that in the 3 U.2 offerings that we have. So each one of them is the 1.6 terabytes and both types of adapter is a little bit slower in the max bandwidth capabilities and the IOP capabilities versus the 2 larger sizes. And when it comes to all the feature codes on the far left of this table, you notice that there's only 2 feature codes for the U.2 and there's 4 for the add-in cards. The reason for that is the add-in cards have both IBM I and AIX Linux feature codes, just like the U.2s, but we also have the support for low form factor versus full height form factor on the tailstocks. We don't need to worry about that in the U.2 form factor because they easily slide into the 2U server or the 4U server. So that's the only reason why you see a difference in the feature codes there. Next slide. One other new item we have that was also part of the G model announcement was a new 2-port 16 gigabit fiber channel adapter. So this adapter, as we're coming out right now, is a new adapter supported only on VIOS and AIX at this point in time. It's supported across all of our Power VM servers, so it's not something that's unique only to the G model, but we announced as part of the G model line. These adapters should be equal in capabilities and performance as the existing adapters. It's just we're expanding the option of having these new fiber channel adapters out there for you, so you've got a slightly different set of choices on your 16 gigabit network SAN solutions. And as like the other adapters, if your backbone or your switch framework for your SAN is not at 16, but it is running at 4 or 8 gigabit per second, these adapters, like the others, will also auto-negotiate down to the appropriate speeds. The pricing on these adapters, I can mention that these are slightly lower price than the existing 2-port 16 gig fiber channel adapters. One of the reasons for that is, as you can see right now, they are only supported on AIX and VIOS. We are looking at how can these be supported in Linux future date, and I'm not sure right now what we're going to be doing with IBM I, but that is one of the reasons why it has a nice entry-level price for you versus the other ones. Okay, next slide. So I know I've seen a whole bunch of questions come through on the Q&A side. I don't think I can get to all of them in the next 4 minutes here, obviously. What I will do is ask Joe to send me all these questions, and I will try to get back to answering them. A lot of them I may have to find a way to post them somewhere because I'm not sure if we can see everybody's email address for them. If you don't see me answering any of your questions, like I said earlier, feel free to send us an email, and we do respond to our questions when they come out to us.
And I can post them if we answer the questions and get a file back. I can post it on the wiki. So
okay, that works out great.
For anybody.
Yeah,
fantastic.
That's awesome. Yeah. Okay, let me just show you guys here. I've not walked through all these charts. I have it just put as a reference dimension, but you can see, you can find in this overall scale, enterprise scale family chart. These are products that I am responsible for. All the Power VM servers, right? So, and you'll see some information about the systems being updated. I have some big pictures, right? So these systems are my babies. So who doesn't like to show baby pictures, right? So I wanted to make it very big here. So you have a comparison between A and G models. You have a table here, green highlights, and also some more descriptions, same for the S922. I'll just go over these charts, same for the S924. Look how beautiful they are. And all the specs here that highlights the changes in the hardware. One last chart I wanted to mention to you, make sure when you are comparing and assessing the best systems for your infrastructure, that Power 9 systems, they all come with a hypervisor already, right? No license extra cost. So you get the hypervisor there, right? So all the workloads you will run on that is going to be virtualized already, right? We do have a hard partition feature that makes it really unique, right? Because you can virtualize, but it's still very attached to the firmware of the system, because IBM does both of this, the software and the hardware. So it's really a symbiotic solution. And you should consider that when you're comparing to competition, right? Not just the system, but hypervisor as well. And then we make it a fair apples to apples comparison. So consider SWAMA, consider software maintenance, consider other stuff, because it makes it much more fair conversation, and you see the value on the Power Platform even more. The OpenShift discussion, I'll lead it to another day. There's a lot of things to talk to, but OpenShift and, not OpenShift, Cloud Paks discussion, have them supported on Power, make the assessment, and that's another discussion for another day. And this is it. Thanks for your time. I could just stay here talking much more, but we don't have time anymore. And here are the contacts, the emails, and thank you for your attention today.
And you showed that one chart, Daniel, that showed all the different models. So maybe to note there that the G models are just like the A models. There's G versions of the A models, but not the H or the the HANA specific,
Exactly.
like the H924, the H922. I don't know if we're planning on doing anything there in the future.
Yeah, I think I mentioned another chart. The H models will be refreshed. The plan is to have a G4 version of them by the end of the year,
Okay.
mostly in November. And the L922, there's not a date yet for this system, right? We are actually assessing that. But the thing was to have the S systems to be the front runners, right? So they support Linux, support AX and IBMI. So for hybrid multi-cloud environments, mission critical, these are the front runners.
Okay. So I want to say thank you to Daniel and Douglas for presenting here. I really appreciate it. A lot of good stuff. Thanks also to Nigel and Dan Sunt also got on and was answering some questions. Nice to see those. What I'll do is I'll take the Q&A log. I kind of sanitize it by taking out all the emails and stuff just for privacy reasons. But I'll take that. We'll get whatever questions we can answered, and then I'll post that on the wiki as soon as we get that back. All right. So it'll be up there with the presentation materials. And the link to the replay will be on the wiki as well as soon as I get it all uploaded and all that stuff figured out. So thank you very much, guys. And I don't have anything set up, you know, I don't have the webinar and stuff set up for next month yet, so you'll have to wait, and I'll send out invites for next month, everybody. But otherwise, stay safe, stay healthy, and have a good month.
Yep. Thank you for your time, guys.